Welcoming Michael Walker here. He has been part of or was part of the National 2600, the local chapter for a long time. Moved 6 years ago, something like that. Was a treasurer for a while, longtime Freaknik attendee and speaker. So we're glad to welcome him back. Currently, Michael is a mobile device developer with Baxter Healthcare. I feel your pain with healthcare. Michael has been working as a contract developer for various companies for the past 2 years. Round of applause for Michael. Thank you.
About me. Well, first of all, I guess the title of the talk, Designing Your Code for Testability, Moving Towards Clean Code. So, as developers, I'm sure, who are software developers in here, first of all? Raise your hands. Okay. I'm sure you've heard the term clean code. I'm sure you're at least vaguely familiar with the general concept. So, I graduated. I was what you would call now a recovering academic. I graduated Youngstown State with a computer science degree, went to Vanderbilt, got my master's, pursued my PhD, and then decided I would go into industry. While at Vanderbilt, I helped develop the Coursera Android app development specialization. We've helped teach over 200,000 learners, their term for students. And I was a full-time adjunct faculty at Youngstown State teaching CS and IT classes. So things ranging from basically your A+ certification type of content in a system configured maintenance course up to basics of object-oriented programming and distributed processing in another course. Since 2019, been a full-time software developer in Android, and since February of last year, been doing consulting. So the point of this talk and what I'm hoping you're going to be able to take out of it is, so first of all, why should I test? And generally nowadays we understand that this is important, but sometimes it's good to actually think about going back and understanding that. And then what types of tests are there? And so that is useful for figuring out where you should spend your time, what can give you the biggest benefits, things like that. And then how can I get my company to allocate me time to write tests? So, and then we're going to go through, most of this is actually going to be showing code and walking through an actual example to try and demonstrate the points. So, well, why should I test? One, you don't hate your own soul. So if you're programming and you don't have unit tests at least, you are going to be in for a bad time, basically. Who here does programming professionally as a job? Okay. Do you have unit tests? Does anybody not have unit tests on their code? Okay, so no hands were risen or rose for that portion. So, as a joke goes, you haven't angered all the gods and then all the known universes. So you want unit testing, at least. Do you want your code to not only become more correct, but more maintainable long term? If you want better maintainability in your code, it is recommended and good design to have testable code because of a couple reasons, and we'll get into those. But primarily, well-designed code is more easily testable. So you can, they go together hand in hand, and when you have code that is more easily testable, you can help prevent bugs from getting back into the system and regressing into the system. And most importantly to some people, if you want a career in software development, you need to know how to write tests, how they work, things So what types of tests are there? Primarily this talk is going to be talking about just basic unit tests. The example app I'm going to show is Android, but the concepts are applicable in any, if not most, if not any languages. And this is a quote from Atlassian. Unit tests are very low-level tests and close to the source of the application, if not generally the source itself. They consist in testing individual methods and functions and classes, components, and modules used by your software. Unit tests are generally quite cheap and to automate and can run very quickly by a continuous integration server. So that's the key to unit tests. They're cheap and quick to run. So you can automate them running over and over and over very quickly and very fast. So there are, in Android at least, some nuances to unit tests. There's local tests, which are the classic unit tests, and there's also instrumented tests. Local tests, I'll list a second, they execute on your development machine or on a server, so they're very fast. They don't require a test device running. You can just run them in native code, so in Android, Java/Kotlin, and you compare that to an instrumented test. This needs to run on a device of some type, so either a physical device or an emulated device. Instrumented tests are generally ran to test UI components and UI flow and logic. And in Android, they're orders of magnitude slower than a traditional unit test. And we'll get into that, why that's important here in a minute. So, manual versus automated testing. A lot of this on the screen is just listing things that you probably, as a software programmer or developer, intuitively understood, but may not have seen them listed like this. So obviously automated testing is the goal. You want to be able to have your tests run, at least as much of your testing run automatically over and over and quickly. So CI/CD. Who here does, or I'll rephrase this. Yeah, who here knows what CI/CD is? Okay. Who here uses CI/CD? Okay. For the record, one hand timidly went up. So, once you go to using a CI/CD server, you'll never go back. At least I can guarantee you that as an Android developer. I've worked on projects that had CI/CD in a pipeline that enabled automatic distribution and all of those things to QA and then eventually to the App Store and all of that. Once you have that, you'll never go back to a release process by manual means. So, like I said here, automated release process story time. So, why is CI/CD so important? Because it takes the human individual machine and human individual developer and their machine out of your critical flow for your app being released and published and tested and all those things. I worked at a company once, I won't say who, but they had a developer who had the keys to publish the application, and they went to Cancun and were almost not let back into the country because they thought they had COVID, and so they had to wait until they tested negative twice. So you don't want that type of scenario, and the canonical example of that is somebody gets hit by a bus. What happens when that scenario occurs? So you don't want that type of bottleneck in your application release process, and so you generally want to move towards continuous integration. The key to continuous integration, a CI/CD server, is having lots of unit tests to check that your code hasn't broken. So over here on the right-hand side is the link down at the bottom at Lycian has a list of what are the types of software testing. And they list 7 types: unit, integration, functional, etc. And off to the right, I put A and M for manual and automated. And you want as much of each of these tests to be automatic as possible. So theoretically, you want to automate all of them. That's not realistic, but unit tests, integration tests, functional tests, which it makes distinction on the site of functional tests are a type of integration test that return the right result, which is a little weird to me that it makes that distinction, but we'll go with it. End-to-end tests, some of those you can have automated and some you might want to do manual. Acceptance testing, where you have some type of product owner or management approving a release, you want that to be manual, things like that. So I said, how do you get your company to actually care about testing? So this assumes that you understand that, or you have an idea, you want to work towards testing, and you want to get buy-in from management and other developers. If you don't get buy-in, if you're looking to do testing, you're looking to have more reliable software. If the management doesn't want to invest time into creating tests, possibly look for another job. That's my personal opinion. So if your fellow developers, they give you a lot of pushback on writing tests. That's not a great sign also. Some known phrases, I've said these in particular. It takes 5 to 10% longer up front to write tests, but saves 30 to 40% later when debugging problems. Are those numbers completely made up out of my head? Yes, but generally they actually do hold true, and that pattern is applicable. And so if you explain it that way to a lot of management, they'll be more receptive to that concept. Writing tests before fixing a bug helps prove that the bug was actually fixed. So therefore saving time and not having partial fixes to bugs go out into production. Having to fix it twice helps also in the long term, preventing bugs from regressing back into the code. So like these are pretty straightforward, but this is more of a, at least this part here is just to, so everybody, we're all the same basic standard. And so I made a repo, it's public, it's up there. Intro to Designing for Testing, it's on my repository, M.A. Walker. Any questions so far? I'm going to structure this sort of like a course lecture, because that's how I'm good at this. Are there any questions so far? Okay, so most of this was just a preamble to start looking at the code and designing, understanding the concepts. Testing is good, basically. So, let me show you. I just made a sample app out of Android, and it auto-generated this screen for me. I altered the logic to, when you press the button, you'll see a toast down here that says the name of the app. Pretty straightforward, but this is enough to actually demonstrate a couple key concepts that are going to be important. So, the app itself is super straightforward. So actually, let me ask again. Who here is a developer and has not written unit tests?
And not what?
Not written any unit tests or any testing before. Okay, good. No hands went up. I think I saw maybe one go up, but we're going to ignore that for everybody's sanity. I'm using Kotlin and Java, Kotlin in here. This uses JUnit. This example is Android. The concepts are applicable in other languages, frameworks, IDEs, whatever. So I wanted to keep it as simple as possible to demonstrate the principles, not the tools that I'm using. So we have a fragment in Android, that's the screen. I have an object called first fragment logic. Sorry, it's huge on my screen, so I'm trying to navigate it. And it's a first fragment logic object. This contains a database. In the database, we're just passing the name of the string up. So this database has a resource grabber. Yeah, I'm not being creative with naming right now. And this returns either a empty string or it calls get app name, and if that's null, it will return an empty string. So anything calling database will never have to handle nulls. So we're basically handling any null checks here. Resource grabber, this is sort of magic hand waving, but this is actually accessing through the application. This is an Android specific part, but just so you're aware. I'm pulling this value from a string resource, and I'm doing that by having reference to the application class that I'm running. So, resource grabber, the trick to making this work is on your, if you're familiar with C++ or whatever, you're familiar with main. The main in Android applications is buried inside the internal libraries and API. What you actually consider your main basically is an on-create. So on the creation of our application, we assign the application to the resource grabber. Pretty straightforward. I'm not trying, there's no tricks here. This would be a memory leak in normal cases, but since the application's there's only one, it's a singleton, the object, which is a singleton in Kotlin, is fine to store the application reference. So, let's say we want to test our database class. Anybody here familiar with JUnit or testing in Java? No? Okay. So, quite easy. You can generate and you click test and it'll generate the test file for you. I've already done that. And it's here. And I've made a test. Intro to designing for testing. Now, we run the app, we'll notice that's what it says. Great. So it's expected that string when I call get app name. Here's our database. Going to run it. It's going to fail. Does anybody happen to know why? No? Okay. It's a little, I just mentioned it, but it needed reference to the application. And it doesn't have an application because to make this work, it got the empty string. To make this work, what it would, come back here. Run it. We got 2 instead of the empty string this time. To make this work, this instead of just being classified as a plain unit test, this would be a instrumented unit test. So this would need to run on an actual emulator or device. This is orders of magnitude slower. So the goal in this is to be able to refactor this code so that we can make this run as a non-instrumented unit test. So that nuance there of it, that's an Android thing, but the concept holds true no matter what. So let's say you are writing Laravel or some type of content management system. That's PHP 1. You're writing a API with Laravel, and you want to test that your code works when it gets information from the database, that it's parsing the information, it's formatting it, it's doing some logic. Well, obviously you don't want to be pulling information from the database every time that you're going and running the test, because you want the test to run fast. That's the idea of unit tests. Any test that you can automate and make it fast, that's the goal. So in this case, what I'm going to show you is I could make this work, this test in particular. I could make this work if I set up of making it run on an instrumented test and run on the device, on the emulator. But literally orders of magnitude, well, I don't know anymore, but it was orders of magnitude slower. I would assume it still is. I'm to the point where generally I don't make instrumented tests anymore. I make everything so unit tested that you don't need instrumented tests, which makes the testing go way faster. So, okay, so here is the issue with the database. Is anybody familiar with concepts with testing, how you would try to refactor this to make it more easily testable without a DI framework? Giving away the answer if you know it, if you don't. Okay, so the real answer in most companies is a dependency injection framework. So in this case, in Android and Kotlin, HILT. So that isn't the only way to do this. I'll show you. There we go. Okay. So Kotlin has the ability, what's called parameter defaults. It might make more sense if you're not familiar with Kotlin. That's what this is doing. It's instantiating an instance of resource grabber. If you call this database, if we follow this database doesn't actually have anything in here, but the code compiles right. So what's actually happening is the constructor for this object is using the default parameters here. So most modern programming languages have this in it. I think Java is about the only one that doesn't, at least Java up till, I think 11. I haven't kept track with 15, 19, 47, whatever they're up to now. This is nice because you can inject a value into the constructor. And that becomes useful for testing. And we'll show you why. But you're injecting the object itself. You have to create this resource grabber. If you make it an interface, and you give that interface the same method that resource grabber has, this will now work also. Now, does anybody have an idea why I did that? No? Okay. So the reason I did that is to enable me to swap what I'm using in the test so that I don't have to use this actual resource grabber that makes use of the application. So therefore I can what's called mock this or make a test version of this with a version of this interface, an instance of this interface that doesn't require connecting to a running application. So I can make now my unit test much faster. And I don't have to care about, oh, is it running on a device? Is it running on an emulator? Like, did I lose network connectivity? No, none of that. I don't have to deal with any of that hassle. So, whoop, wrong one. Val. Test resource wrapper. Don't worry about the syntax. It's a little ugly, but what I'm doing is I am creating an instance of this interface, and whoop. Another reason, as I told my students, I'm not the best programmer. I've just been beating my head against the wall for 20 years and have ran into a lot of problems. So, oh, there we go. Ah, yes. Now I'm passing in that test resource grabber object into the database, and there we go. This is a note. Don't, I think, did the audio go out? Test, 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 test. Oh. Well, I can speak up. That's not a problem. We'll just sort of hang. I am having a... Oh, I think I know. Yes. I didn't make the interface. It expect an interface in database. my test passed. So, that actually went a lot quicker than I was expecting. So I'm basically done, but I'm available for QA if anybody has some questions. Yes?
I came in a little late, like 5 minutes.
I'm sorry, then it's $20 per question.
Would you say what you're doing here is more like an SDET role or something of that nature? Because we think of testing.
I'm sorry, S what?
SDET, software development and test.
Yeah, this is, I would consider this a, I would teach this to sophomores in university for CS. So, I actually went a little, well, I would say a junior, senior level of actually designing tests. And
Would
so,
you map this back to a functional or operational requirement for the test, or? Testing nerd here.
Yeah, I would say that this is a functional requirement of the test itself to be able to run the test without the test. Test. Oh, here we go. Sorry about that. For the record, the question was, would you classify this as a means of a what functional, or what did you say?
When you look at testing, testing's changed a lot, obviously,
Mm-hmm.
in the past, I'd say in the past 5 years. We went from, standard, from the developer side, you're going to write JUnit and you can test it for code. Then it's usually going to move to a functional tester and then maybe performance engineer, security, there's just a life cycle to it. But there's been a combination of a lot of roles such as site reliability engineers or software development testers.
Yeah, I don't really think often that those are distinctions without meaning unless you're in the context of specific organizations. So the question was, there's been a lot of evolution of software development testing and just software development in general. So the unit testing and then integration testing and performance testing and security testing, some of these things have merged into different roles. I could see easily every single one of those still being separate roles where on a large enough project, there's entire teams on each one of those things. And so, sort of like DevOps.
You're still going to map your test to a requirement, right?
Oh yeah, like this was a general concept. And so, this is the basis of how to, in my opinion, write general good unit tests. And the trick is to inject your dependencies into the class that you're testing. So here, we're not using any frameworks. We're not using mock or Mockito or Power Mock. There's a bunch of different mocking frameworks that would enable you to mock these things. And then for dependency injection, Hilt, Dagger, you could write your own using composition root. That's sort of my personal favorite, but Hilt apparently has come out and is a lot faster now for Kotlin. It actually parses Kotlin, which is nice. In production environments, if you don't have some type of dependency injection, either framework or tool set or pattern, doing this becomes almost impossible, because what I just showed you is moving one of these objects to a constructor. It was trivial, basically. What? Test? Okay. Anyways, the demo gods are definitely playing with us. Oh yeah, I'm sorry. This is basically trivial. But when you start getting into complex examples with multiple layers, and what the values you may need to pass to make a test gets in it's tractable, but it's just tedious. And so you move to some type of framework or tool set or pattern to facilitate that. In Android, that's generally helped. So, so what I wanted to get back to on this is part, if you're familiar with software design patterns, this is part of the builder pattern, or fulfills most of the role of the builder pattern versus the traditional design of it. So traditionally, what's the builder pattern? You give parameters and methods into a builder, then you type build, and it delays the construction of that object. It builds it with all those different parameters. In this case, we click database, and one has no parameters and one has a parameter. So this in Kotlin is called name parameters and parameter defaults. It enables you to have different, one constructor with different parameters. And so this doesn't enable delayed generation of your object like the builder pattern does, but in reality, most people use the builder pattern to get this effect. So, test. Okay. Not blow out the speakers. Okay, so we're good now. Yeah, so that's basically the beginning of it. I mainly wanted to leave time for Q&A because to me this is pretty simple, but I understand that I might not be doing a great job explaining it to everybody, and that's sort of how I taught my classes too. I always had like the extra half of the class to questions. Yes.
I was just going to ask, how meta can you get with this? Like, is it a common industry practice to have tests that test other tests? Like, when do you reach a certain point where...
You don't want to do that.
don't?
So the question is, how meta do you want to get with this? Do you want to have tests that test other tests? And that is a spiral that can go deep.
Yeah.
So it is not bad practice to have some unit tests or some tests at every level of testing that are just sanity checks.
Yeah.
Sanity check, 1 equals 1. If that test fails, you know you got a problem with your testing framework, not the other tests you're writing. Whereas if all of your tests fail and you have that test in there, you don't know anything about your app. Your app might be fine, it might be your testing framework. But if 90% of your tests fail and that sanity check passes, then you have a good indication that your app is majorly broken. So, but you don't want to test the tests. At some point you just have to, so networking. A networking library, you wouldn't write a unit test. You test that it works, and then you mock it when you're testing things that use the networking library. And if the networking library fails, you'll know it, but you don't want to really test that. That would be not a unit test, but that would be some type of, at least a instrumented test or a full integration or end-to-end test. So this is more approaching just get some unit tests, get there. Once you get there, moving to the next step, that requires more domain-specific knowledge of whatever program you're writing, what programming language, etc. Yes?
I've always explained it when I talk about testing. Unit tests are for the devs in a lot of ways to make sure your stuff is working. And then from that point forward, everything just maps to the requirement. So we're not testing or test for test. We're saying this is a requirement. It needs to do X thing. Test case says, did it do or did not do X thing? We write the test to satisfy the requirement for the test case.
Yeah, I would agree generally with that. If the link, the list on Atlassian had instrumented tests that would also be, I think, dev oriented, like more than one module interacting with each other. But that might, again, that's gray area. You could have like different departments working on that, and that's.
It could be the same person.
Yeah, it could be the same person. I mean, there's lots of things. It really, what matters is more consistency with your terminology. If you have a process in place that is working and valid, as long as that you're consistent with that, I think that's what more matters. Whether it's the naming of the roles, because.
Those are pretty common terms.
Oh yeah, no, definitely. I've seen others, but they're definitely common. Any other questions? Yes.
So, how much time would you put into like developing your testing? Like, how would you describe how unit testing and other forms of testing play into like scope creep? Is it really important to like get these tests done, or how would you?
Yeah. So the question is, how much time would you invest into your testing? And I'm going to split that into two parts. One, the platform, and two, individual tests for a feature or bug that you're working on. So the test platform, a significant amount upfront, if needed. It shouldn't be, but if you have new developers, new framework, you're doing some like R&D project, you're trying to figure it out, get unit testing working. Realistically, in most, like a business application, it's not going to be difficult to get testing up and running. But I would spend the time needed to do that. At least get it so that your code is testable. One phrase I'd like to say, the interview type question, not every line of code needs to be tested, but every line of code needs to be testable. And there's a reason behind that. It means that you don't need every branch tested guaranteed to have a viable product. It might be an old application that wasn't tested to start with, and it's already shipped, and you're coming on and you're starting to do testing. There's a lot of weird scenarios like that. But you want to work towards being able to test that code moving forward, or things like that. A new code. You want to at least write some basic unit tests at the bare minimum to make sure that the main operations, like a smoke test, where at least 80-20, at least 80% of the code is well tested. How much you can do that, I've worked some places that tests weren't required, and you didn't have time for tests. That's not great. And I got to the point where I worked on my own to get the testing working so that I could write unit tests in the code, so to save myself time, because I was losing time missing edge cases. And so I'd write tests for those edge cases, and when I knew all of those were working, then have them solved. So that's why I say not every line of code has to be tested, but testable. That's sort of my, I wouldn't say golden rule or anything like that, but I try to get that way. And so if like in this case, when this was down here, this code works, but testing this isn't easy. So moving it, making it so the code is more testable is the goal, if that makes sense. Have an opinion or addition or comment? No.
I'm good.
I always like to hear from other people's add-ons, so. There. So yeah, that's it. Any other questions? If not, I'll dismiss class here. I will expect your homework next week.